Hello, this is How to Save Humanity in 17 Goals, a podcast brought to you by Nature Careers in partnership with Nature Water. I'm Fabio Prizzi, Chief Editor at Nature Water. This is the series where we meet the scientists working towards the Sustainable Development Goals agreed by the United Nations and world leaders almost a decade ago. Since then, in a huge global effort, thousands of researchers have been using those targets to tackle the biggest problems that the planet faces today. In episode 12, we look at Sustainable Development Goal number 12 to ensure sustainable consumption and production patterns, and hear from a textile engineer looking at ways to combat fast fashion.
My name is Sonja Salmon. I'm an associate professor in the Department of Textile Engineering, Chemistry, and Science at Wilson College of Textiles at North Carolina State University in the United States. The United Nations has these Sustainable Development Goals. One of them, number 12, is to ensure sustainable consumption and production patterns. And this is really important to me. My research is in textiles, and as we all know, textiles are a major consumer product for apparel and home furnishings and a lot of other uses. And these are materials that we wear them, but then they have an end of life, and we need to be very thoughtful about what happens to them afterwards. And currently there are problems with accumulation of waste textiles. And so this is something that's important to me to see how we can apply this principle of the sustainable consumption and production patterns to the textile industry. Textiles are obviously all around us in our lives. I mean, we wear them, we have them, sheets and drapes. They're in our homes, they're in our cars, they're even used in airplanes and very sophisticated equipment. So, and agriculture as well. So we know that textiles are abundant and we need a lot of them to have the lifestyles that we do. There has been a lot of change in the amount of fiber that's been produced for textiles over the years. For example, if you go backwards, say to around 1975, global fiber production was around 33 million tons. Now, if you fast forward to current production, it's actually around 113 million tons. And fast forward to 2030, that amount would be up to 147 million tons. That's a projection that's been reported by the Textile Exchange, which helps make these statistics available to the public. The textile industry has an estimated global market value of $1 trillion. And within that, clothing accounts for more than 73% of that value. The other parts would be household goods and technical textiles. The issue with clothing is that there has been, in recent years, a trend called fast fashion, where garments are purchased mainly because of their appearance, because they're trendy, but they're not really designed to be long-lasting. So this has contributed to a change in the average lifespan of a garment. It used to be that garments would be washed and worn and even mended and kept for many, many years. But now the average lifespan of a garment is somewhere between 2 to 5 years. And so if you imagine that as the world population is increasing and wealth is increasing and more people have more stuff, and the lifespan of the garment is decreasing, this is really going to contribute to increasing volumes of textile waste, and that's really an issue that needs to be addressed. So in addition to these volumes of textile materials that are being produced, you also have to think about how they are produced. And textiles as an industry uses a lot of water and uses a lot of hot water. So the water, which is potentially starting to have chemicals in it, those effluents, if they're not treated, they could be damaging to the environment if they're released in an uncontrolled way. and then the amount of energy that's required to heat water to either apply the chemicals or often simply for washing afterwards to remove the chemicals. Heating water is expensive, and so that demands energy, and energy is often delivered from fossil fuels, and fossil fuels produce carbon dioxide, which is a greenhouse gas. So there is a pretty strong connection between the environmental footprint of the clothing that we wear and, say, the greenhouse gas emissions or the water quality changes that are happening on the planet. Another aspect of the environmental impact is transportation. What happened in the industry over the years was a lot of movement from one region to another region, and that was often driven by labor costs because textiles require a lot of manual labor, especially the cutting and sewing process. So those parts of the process are done in regions where labor is less expensive, and then the materials have to be shipped back to the place where consumers actually want to purchase them, and that will incur shipping charges and again, using fuel consumption and contributing to greenhouse gas emissions. In addition to these changes in the volumes of textiles produced, there's also been some pretty fundamental changes in the types of fibers that we wear. Before 1950s, this is less than 100 years ago, all the clothing we wore were made from natural fibers. Cotton, wool, silk, linen. In the 1950s and 60s, synthetic fibers came on the market. Again, less than 100 years ago. And these synthetic fibers are high performance, they're cheap, they're very good in many, many ways. And so they have taken over from the natural fibers to the point that one single type of synthetic fiber, polyester, it has a technical name called polyethylene terephthalate, PET. You might see that. PET or PETE, you might actually see that abbreviation on your plastic water bottles. That exact same material that makes plastic water bottles is also making your polyester athletic shirts and things like that. That material is extremely high performance. It is extremely cheap. It dominates the market. It commands by itself about 50% of the entire fiber market. And it originates from fossil fuels. And it does not degrade in nature. So if I should share a little bit about my background, part of the reason I would do this is because I want to inspire young people. I want to inspire young people to follow their passions and follow their dreams and believe in themselves, believe in what you care about. Because if you care about it, chances are other people care too, and you'll find your place, you'll find the thing that matters to you. So I'm here working in the College of Textiles. Why would I even have chosen textiles? It's because I like to sew. Actually, from a very young age, I just enjoyed the texture, the beauty of fabric, and I have this creative bent. I liked to sew things. And so that stayed with me. I mean, that's just my creative spirit. Then I went to school and I started to learn this amazing science called chemistry. And chemistry helped me understand how these beautiful materials that I was sewing, how they actually worked, where they came from, why they behave the way they do. And so to me, chemistry was a way for me to understand a very fundamental passion I had for a kind of a thing that made me feel happy and artistic. So that's what brought me into the chemistry world. And I try to still use that same philosophy as I'm doing my research. I'm curious. I want to understand why things work, how things work, and what I can do as a scientist to help the world be a better place. One type of textile that pretty much everybody has in their closet is a t-shirt. And chances are that at least one of your t-shirts is a polyester cotton blend t-shirt. Mostly because it's inexpensive and high performance to make the t-shirt that way. You get both durability, low cost, and comfort. The technical performance comes from the polyester. It's a really strong fiber and it's very inexpensive. The comfort comes from the cotton, which is absorbing moisture so that when you're jogging on a sweaty day, it helps take the moisture and the sweat away from your body. So that's the reason why t-shirts are often made from this blend. Problem with this t-shirt, though, is these two types of fibers are really different technically, but they do represent the two most prevalent types of fibers in textiles today: the polyester, the dominant one, and cotton, which is the second most prevalent. So if you look at those two fibers and think about how are we going to recycle this t-shirt, what do? Well, the t-shirt problem, the blended fiber problem, is the same problem you have when you have glass, plastic, and paper in your garbage bin. You need to separate them. You need to put the glass bottle in one bin. You need to put the aluminum can in a separate one, the plastic bottle in another one, and the paper in another one. Let's focus on the newspaper and the polyester water bottle. That's kind of equivalent to this polyester cotton t-shirt because paper is also made from the same polymer that's in cotton. So we need to take that 50-50 polyester cotton t-shirt and separate it. If you can successfully separate this t-shirt, let's say now you've got the polyester purified, then you have all kinds of things you can do. There are many companies working on recycling polyester now because it's such an important material. So companies, big name companies that you would have heard from before, like Eastman Chemicals, they've announced a major new facility that's going to be dedicated in the United States specifically for recycling polyester. Another company that you may not have heard from before is called Carbios. They're located in Europe. They are actually applying biotechnology to the problem of polyester recycling using enzymes that have been specially developed to degrade this polymer to chop it back down to its monomer parts so that you can resynthesize it. As long as cotton is going to be long enough to respin it into a yarn, of course, that's the best way to recycle it. But as you're trying to recycle materials, usually they're stressed or mechanically damaged, and that breaks the fibers into short fragments that can't be recycled directly. So in that case, what you have to do is you have to reprocess the cotton in a completely different way. To do that, you dissolve the cotton into special solvents. And when you've dissolved it, you get this thick, viscous solution that you can extrude. And extrusion is like pushing this solution through something that looks like a shower head. And you get these yarns, these strong, long filament yarns. That type of fiber is something that you may know as rayon or viscose. So that's very similar to cotton in its properties. It just has a different form factor. It's a long fiber rather than a short cotton fiber. So these can be reused, but that process of recycling the cotton is pretty expensive and it requires special kinds of solvents and special kinds of equipment. So that's one gap, is it's expensive to do it that way. In my research, I look at this 50-50 polyester cotton blend and I think to myself, okay, well, what can I do? What can I do about this? I don't myself have technologies to do much with the polyester, but I do have experience working with enzymes. I used to work for a major enzyme production company, and so I learned a lot about different enzymes and how they can degrade natural materials. So there's one category of enzymes called cellulases, and these cellulases are very efficient at degrading materials like cotton and other types of cellulosics like linen or ramie or even rayon and viscose. If I apply these enzymes to the 50-50 polyester cotton blend, I will degrade the cotton portion and I will leave the polyester intact and undamaged. When I degrade the cotton, I degrade it into such small pieces that they simply fall out of the fabric structure. The only reason a fabric structure remains intact is because the fibers are twisted together. As soon as the fibers aren't long enough to be twisted together anymore, they'll fall apart. So my chemical way, my enzymatic way of deconstructing this fabric is how I help remove the polyester and the cotton from each other so that I can take the polyester and to throw it into its bin and take the degraded cotton and throw it into its bin. Now you have the fibers separated into these two bins. The polyester, as I mentioned, there are major companies working on finding recycling strategies for that. The other bin, where I have my degraded cotton, now what am I going to do with that? So first of all, what you get when you degrade cotton is you don't get just a pure liquid. Some of it turns into a liquid. It's like sugar water. So you can break this all the way down to glucose. And if you did, you could feed this glucose to microorganisms in a fermenter that could turn it into chemicals like ethanol, which is a drop-in biofuel, or other types of higher value chemicals that you could use to make commodity materials. So you could take your waste cotton and turn it into biofuels. That's absolutely one good use for the materials, but biofuels themselves don't have a lot of value. And so this recycling requires money. You have to invest in the recycling process itself. So you really need some higher value targets to make this commercially viable. What we learned in our research is when we are degrading the cotton into smaller fragments, we find what we call cotton fiber fragments remaining in the slurry. These are really strong, highly crystalline, tiny, tiny little pieces, but they don't easily degrade. We think that these little tiny pieces could have a lot of value in fabricating materials, especially additive manufacturing. That's 3D. Most of us know that by 3D printing. So what if we could take this waste cotton, these little tiny fragments, and use it to recreate things by additive technology? So a specific example for 3D printing, if we just stay in the textile theme, would be, say, buttons and zippers, even accessories, maybe for making handbags or components that you would use in shoes, grommets, all these little hard devices that could turn into, instead of making them out of plastics, why not make them out of this high-performance cellulose polymer that came from plants? So we're using bio-based materials that used to be our old clothes and turning them into high-value composites that can be used for very sophisticated materials. And that would give us the value driver to help us do the recycling. Technically, there are going to be some challenges in it, but that's why we're scientists, right? That's what we do. We look at these problems and we say, this is a challenge. How am I going to deal with it? And that's, so we're not daunted by the idea that it's hard. We're curious because it's hard. We're curious, how can we make this easier? What can we learn from how nature does this to make this in a better way and a useful way, and a thing that will also agree with what nature does, which is makes materials like trees, which are amazingly strong composite materials that stand up for hundreds of years, but eventually, when they're dead, they fall over, they die, microorganisms take care of it, and they disappear. So we need to use that same kind of strategy in our use of materials. The concept of sustainability has two elements that push against each other all the time, and it makes it really hard. But just acknowledging that those two elements are there is important. On the one hand, a business wants to be sustainable. A sustainable business means you're making money, you're hiring employees, you're doing well. But that doesn't necessarily mean that what you're doing is the right thing. And then there's the sustainable, call it from an ecosystem point of view. Are we damaging our environment? Are we making sure that our water is clean? Are we not harming our air? That can push against this need to have a business profitability. So that challenge is always there. The goal is to find ways to make business where the revenue stream actually derives from things that will help benefit our ecosystem. So that's what we really need to be looking for. We need to be looking for business models where we're using materials that can be recycled, that can have another life. And yes, we're going to pay for them. As consumers, we're going to pay to have that material because we need to use it. But then we're also going to put it in the right place at its end of life so that it can be recycled and reused. And there will be value streams in that so that people can have good jobs and make good money. That would be what we call the circular economy. We want to make this industry to be a good and responsible industry and have a sustainable future also for the business elements. So the whole industry cares about this, and they are collaborating and finding ways to join forces on technology development and even trying to build new business models, that would allow recycling strategies to actually have a foothold in moving from what's called a linear economy to a circular economy. How does that look from a business structure? So that is actively happening right now. A lot of top-tier brands are heavily invested in that and building a community so that this can happen together. It's not one company by itself that's going to do it. It's going to be a community effort. The SDGs are very aspirational goals. They point us in a direction. The best we can do is strive towards them and to try to determine, are we going to exactly meet the goal or not at a specific time, is less constructive than to say the goal is there, and as long as we're making progress in that direction and can measure our progress in that direction, that's what we need to be doing. And there's so many things that happen in the world. I think any timeline is going to be a little bit non-specific, but believing in the goals, understanding the goals, and making progress towards the goals is what really matters.
Thanks for listening to this series, How to Save Humanity in 17 Goals. Join us again next time when we look at Sustainable Development Goal number 13, how to combat climate change. See you then.